7 months from now, a machine built in the 1970s will cross a line no human object has ever crossed before, and when it happens, we may not even be able to talk to it anymore. Right now, at this exact moment, that machine is drifting through a region of space, so alien that only one instrument aboard it still has the power to describe what's out there. And what that instrument is picking up is something scientists have started calling, quite literally, the sound of interstellar space itself. Not metaphorically, actual electron oscillations, converted into audio, humming back from a place no living person has ever been. And here's the part nobody is talking about enough. We are running out of time to keep listening. This is the story of Voyager 1, the most distant object humanity has ever built, and the quiet, high-stakes fight happening right now to keep it breathing just a little longer. Let's start with where it actually is, because the number alone should stop you. As of this year, Voyager 1 sits more than 15.7 billion miles from Earth, a distance so extreme that a radio signal traveling at the literal speed of light takes nearly 24 hours just to reach it. Not minutes, not hours in the ordinary sense. An entire day, one direction, for a message moving as fast as physics allows anything to move. And on November 18th, 2026, at 2:16 in the morning. Pacific time, Voyager 1 is projected to cross a threshold. NASA is calling the 1 light day milestone the moment its distance from Earth becomes so vast that a signal sent from mission control and a reply sent back would together consume 48 full hours, an entire 2-day round trip, just to have one exchange. Think about what that actually means for the people running this mission. Every single command sent to this spacecraft is already a conversation stretched across an entire day of silence. Engineers don't get to see a problem and fix it. They see a problem, they wait a full day for their instructions to arrive, and then they wait another full day to find out if it worked. This is not remote operation in any sense we understand from modern technology. This is closer to sending a message in a bottle across an ocean of vacuum and hoping, 24 hours later, that something on the other end is still capable of listening. But here's where it gets worse. Because distance was never actually the biggest threat to this mission. Power is. Voyager 1 runs on something called a radioisotope thermoelectric generator. Essentially, a chunk of decaying plutonium-238 that converts heat into electricity as it slowly, steadily, irreversibly breaks down. There is no way to refuel it. There's no way to repair it. There's no way to send a technician 49 years and 15 billion miles to swap out a battery. The power output of Voyager 1's generators has been declining at a rate of roughly 4 watts every single year, a slow bleed that has now been running for almost half a century. And as of this year, those generators are producing less than half the electricity they did at launch. Read that again. Less than half. After 49 years, this machine is operating on the electrical equivalent of a fading heartbeat, and every single system on board, every heater, every instrument, every thruster, is now competing for a shrinking pool of power that will never, under any circumstances, increase again. And this is where the tension in this story sharply escalates, because on February 27th of this year, that slow bleed almost turned into a sudden collapse. During a routine roll maneuver, a standard operation the spacecraft has performed countless times over its lifetime, Voyager 1 experienced an unexpected drop in power. Engineers back on Earth watched the numbers fall towards something called the undervoltage fault protection threshold, an automatic self-preservation system built into the spacecraft's oldest programming that, if triggered, would forcibly shut down critical systems to protect what little power remained. If that fault protection had activated, the mission team would have faced a recovery process that could stretch for days, transmitted across a communication gap of nearly 24 hours each way with absolutely no guarantee of a clean outcome. Think about the sheer helplessness baked into that scenario. A 15 billion mile distant spacecraft built during the Ford administration, silently drifting toward an automatic shutdown, while the only people who could possibly intervene were separated from it by a full day of radio silence in each direction. This is not a hypothetical. This nearly happened this year. So engineers made a decision that nobody wanted to make, but everybody agreed was necessary. On April 17th, 2026, the team at NASA's Jet Propulsion Laboratory sent a command across that entire 15 billion mile gap to permanently shut down one of Voyager 1's last remaining science instruments, the Low Energy Charged Particles Experiment, known as the LECP. This wasn't some minor sensor. The LECP had been running almost continuously since Voyager 1 left Earth in 1977, nearly 49 uninterrupted years, measuring ions, electrons, and cosmic rays streaming in from beyond our solar system. It had spent decades mapping the invisible pressure fronts and shifting particle densities of interstellar space itself, one of the very few instruments in human history that could claim to have measured the actual physical structure of the region between the stars. And now it's gone. Silenced deliberately by human hands from 150 million miles closer to home in order to buy the rest of the spacecraft a little more time. According to the mission team, this was not a decision made in panic. It was a decision made years in advance. Long before this crisis point ever arrived, the Voyager science and engineering teams sat down together and mapped out, in careful order, exactly which instruments would be sacrificed first, second, and last, as the spacecraft's power inevitably continued to fade. Of the 10 identical sets of instruments each Voyager spacecraft originally carried, 7 have now been shut down entirely, 7 out of 10. What was once one of the most instrumented machines ever launched into deep space has been stripped down deliberately and methodically, piece by piece, to the bare minimum required to keep it alive and talking. What remains now is almost hauntingly small. 2 instruments, just 2, a magnetometer, which measures the magnetic fields threading through interstellar space, and a plasma wave subsystem. The instrument that, quite literally, listens. And this is where the story stops being about power budgets and fault protections and becomes something much stranger, much more emotionally charged, and honestly, much more unsettling. The plasma wave instrument doesn't take pictures. It doesn't measure temperature in any conventional sense. What it does is detect oscillations in the electron density of the plasma surrounding the spacecraft, subtle vibrations and charged particles that, when converted into audio frequencies, human ears can process, produce something that sounds disturbingly like sound itself, drifting through a place where sound, as we understand it, should not exist at all. Back in 2013, NASA released the very first audio ever captured of Voyager 1, moving through actual interstellar plasma. Recordings built from data showing electron oscillations at a frequency of about 2.6 kilohertz, corresponding to a plasma density of roughly 0.008 particles per cubic centimeter, a value strikingly close to what scientists had theoretically predicted for true interstellar space. Sit with that for a second. Humanity has an actual audio recording of what the space between the stars sounds like, translated from real physical data, captured by a machine that had to travel further than any human construction in history to get close enough to record it, and the instrument responsible for that recording, the plasma wave subsystem, is one of only 2 pieces of Voyager 1 still switched on today. This is not chaos. This is the very last surviving sense organ of a machine built to explore, still functioning, still listening, still transmitting back the faint electrical whisper of a region of the universe that remains almost entirely unmapped by anything else humanity has ever built. But here's where everything changes, because keeping even these last 2 instruments alive is becoming harder by the month, not easier. Voyager 1 doesn't just need power. It needs to keep its high-gain antenna pointed with extraordinary precision directly at Earth, across a gap of 15 billion miles, using thrusters that were never designed to still be firing after nearly half a century of continuous operation. And those thrusters are failing. According to mission engineers, some of the attitude control thrusters needed to keep that antenna aimed correctly are already out of use, clogged by residue building up inside their fuel lines after decades of use, a problem with no fix, because there is no backup. Voyager project manager Suzanne Dodd has described the spacecraft's remaining systems in stark terms. Everything on board is now single string. There is no redundancy left. Every remaining component is the only one of its kind still working, with nothing standing behind it if it fails. Think about what that phrase actually means for a machine. Humanity depends on to explore the edge of known space. Single string. 1 working thruster system, 1 working transmitter, 1 working set of instruments, whittled down from 10. If any one piece fails now, there may be nothing left to compensate. No redundant twin waiting to take over, the way there would be on almost any modern spacecraft. This is a machine running on its absolute last operational margins, 49 years past its original 5-year mission design, and every single day it continues operating is, in a very real sense, borrowed time. And even reaching it to give it new instructions has become its own quiet crisis. Between May 2025 and February 2026, Deep Space Station 43 in Canberra, Australia, the only radio antenna on the entire planet powerful enough to send commands to both Voyager 1 and Voyager 2, went offline for major upgrades, with only limited operational windows available in August and December of last year. For the better part of a year, the only communication link capable of reaching humanity's most distant spacecraft was substantially reduced, leaving engineers with drastically narrowed opportunities to intervene if something went wrong. Read that again. 1 antenna on 1 continent is the sole thread connecting Earth to the farthest object humanity has ever built. And for months at a time, even that single thread was only partially available. What most people are not seeing in this story is how close Voyager 1 has come repeatedly to simply going silent, not through some dramatic, catastrophic failure, but through the slow, grinding erosion of margin after margin after margin, until almost nothing is left to spare. In October of 2024, the spacecraft's fault protection system triggered unexpectedly after engineers activated a heater, causing Voyager 1 to shut down its primary X-band radio transmitter and fall back to a backup S-band system that hadn't been used to communicate with Earth since 1981, 43 years earlier. For weeks, the team worked to recover the stronger signal, eventually restoring the X-band transmitter and resuming full data collection by mid-November. It worked. But it worked because a team of engineers, working across a day-long communication delay, managed to correctly diagnose and reverse a fault on a machine older than most of them, using documentation and expertise built for a spacecraft whose original engineers have largely retired or passed away. And this is where the future uncertainty in this story becomes almost unbearable, because the team isn't just reacting anymore. They're gambling on something they're calling, informally, the Big Bang. Not an explosion, but a code name for a sweeping coordinated power conservation maneuver that would swap out several of the spacecraft's older power-hungry components all at once, replacing them with lower power alternatives in a single, carefully choreographed operation. Because Voyager 2 has slightly more spare power and sits closer to Earth, it was chosen as the safer test subject, with the procedure planned for testing in May and June of this year. Only if that test succeeds will engineers even attempt the same maneuver on Voyager 1, no sooner than July. And if it works, if this fragile, unprecedented gamble on a 49-year-old machine actually succeeds, there is even a chance, according to the mission team, that the instrument they were forced to shut down in April, the LECP, could eventually be switched back on. Think about the audacity buried inside that plan. A team of engineers working with a spacecraft they cannot see, cannot touch, cannot physically inspect in any way, planning to perform a coordinated system swap across a distance of billions of miles on hardware whose replacement parts stopped being manufactured decades ago, in the hope of buying a few more years of scientific data from the edge of known space. If it fails, nothing is lost that wasn't already going to be lost eventually. But if it succeeds, it could mean the difference between losing Voyager 1's voice within the next few years, or possibly, just possibly, keeping at least one instrument on each spacecraft transmitting all the way into the 2030s. According to the mission team's own stated hopes, that's the real target now. Not decades of continued operation, not a triumphant return to full instrumentation, just this. Keeping at least one instrument alive on each spacecraft long enough to still be reporting from interstellar space sometime in the next decade. A goal that 49 years ago, at launch in 1977 during the Carter administration, in an era before personal computers existed in most homes, before the original Star Wars had even finished its opening theatrical run, nobody building the spacecraft could have possibly imagined needing to hope for. And underneath all of this technical drama sits something quieter, something almost philosophical, that deserves its own moment of reflection. Voyager 1 still carries the golden record, a phonograph disc containing sounds and images meant to represent life and culture on Earth, launched into space on the off chance that some other intelligence, somewhere, someday, might find it and understand something about who we were. For decades, that record has been treated almost as a symbolic afterthought, a poetic gesture attached to a scientific mission. But now, as Voyager 1's remaining instruments blink out one by one, as its power bleeds away 4 watts at a time, as its thrusters clog and its antenna struggles to stay locked onto a planet growing more distant by the second, that golden record is quietly becoming something closer to the spacecraft's most durable legacy. Potentially, the very last piece of Voyager 1 that continues to exist and mean anything, long after every instrument aboard it has gone permanently dark. The real story here isn't really about circuit boards and thruster fuel lines. And what most people are not seeing is that we are watching, in real time, the final active chapter of humanity's very first journey into the space between stars. And that chapter is closing, deliberately, instrument by instrument, decision by careful decision, right now, while most of the world isn't paying attention. 7 of 10 instrument sets already gone. The imaging system, shut down decades ago, meaning Voyager 1, has been effectively blind since 1990. The plasma spectrometer, dead since 1980. The cosmic ray subsystem, silenced in February of last year. The LECP, silenced this past April. What remains is a magnetometer and a plasma wave detector. 2 thin threads of scientific data, still describing a region of space that no other human-made object has ever occupied. Still being transmitted across a gap that will soon take a full 24 hours to cross. And this is where the tension of this story refuses to resolve, because nobody, not the engineers at JPL, not the scientists who built the original instruments, not anyone alive today, can say with real confidence how much longer this will actually continue. The most optimistic official target is to keep at least one instrument functioning into the 2030s. But optimistic targets and physical reality are 2 very different things when you're dealing with a spacecraft running on decaying plutonium. Clogged thrusters with no backups, and a communication delay that will soon stretch to a full day each way. Every additional year Voyager 1 continues transmitting is not something the mission was designed to guarantee. It's something being fought for, deliberately, painstakingly, one power-saving decision at a time, by a small team of engineers determined not to let this particular voice go quiet before it absolutely has to. Consider what's actually at stake here, beneath the technical details. Voyager 1 remains the only object humanity has ever built that is actively transmitting real, continuous data from beyond the heliosphere. The vast magnetic bubble carved out by our sun, the boundary Voyager 1, crossed back in 2012, becoming the very first human-made craft to operate in true interstellar space. Its twin, Voyager 2, followed 6 years later in 2018 and is now more than 21 billion miles from Earth, its own communication delay stretching past 19 hours. Together, these two aging machines are still, right now, the only working instruments transmitting live data from outside our solar system's protective boundary, a distinction no other spacecraft, past or currently planned, is positioned to match anytime soon. And every single year that passes without a successor mission specifically designed to replace them means that when Voyager 1 and Voyager 2 finally do go silent, whether that happens next year or sometime in the 2030s, or through some engineering miracle even later than that, humanity will lose its only active, ongoing sensory connection to interstellar space itself, with no immediate replacement waiting to take over the listening. There is no second Voyager already built and waiting in a hangar somewhere, ready to launch and continue where these two machines leave off. When this ends, whenever it ends, there will be a genuine and uncomfortable gap in humanity's direct physical presence in the space between the stars. Think about that void, and how quietly it's approaching. Not through a single catastrophic failure everyone can point to and remember, through a slow, deliberate, carefully managed decline. One instrument switched off here, one thruster abandoned there, one antenna upgrade stretching communication windows thinner and thinner, until one day, sometime in the coming years, the last command sent across that growing gulf of distance simply won't come back, and there won't be a next attempt. That is the future uncertainty sitting at the heart of this story. And it is not comfortable, and it is not resolved, and honestly, it isn't supposed to be. Sometime around November 18th of this year, at 2:16 in the morning Pacific time, Voyager 1 will cross the one light day threshold, becoming so distant that an entire day will separate every question we ask it from every answer it might still be capable of giving. Its power will keep declining, 4 watts at a time, with no way to ever add more. Its remaining two instruments, a magnetometer and a plasma wave detector still quietly transcribing the electrical hum of interstellar space into something resembling sound, will keep working for as long as engineers can keep stealing power from everywhere else to protect them. And somewhere in the next few years, possibly sooner than anyone wants to admit, that last transmission will eventually stop arriving. Not because the mission failed, because physics and plutonium and 49-year-old hardware eventually run out of exceptions to make. The only real question left is how much more this fading, single-string, nearly half-century-old machine can teach us about the silence between the stars, before its own voice finally disappears into that same silence for good, and whether, by the time that happens, we will have built anything capable of picking up where it left off,